Lesson 6.4 is about geometric sequences. So in your notes, you have this table on the bottom of the 6.4 intro page. And on the left, it talks about arithmetic sequences. We learned those last semester. Arithmetic sequences, we were adding or subtracting the same number. Geometric, which is what we're talking about here, that's when we're multiplying the same number over and over and over again. So geometric, just like arithmetic, has two key formulas that I want you to know, well, that you need to know for your test. And so we're just going to really quickly review all the key points there are to know about these geometric sequences. So geometric sequences, okay, the key here is that everything is being multiplied by the same number. So multiplying by the same number over and over and over again. And so it'll give you a list of numbers. So for example, I'm kind of going to write small up here, an example. If we start at 3 and we keep multiplying by 2, 3 times 2 gives you 6. 6 times 2 gives you 12. 12 times 2 gives you 24. So we start at 3, we keep multiplying by 2, multiplying by 2, multiplying by 2. That's always going to give us the next number. That's an example of a geometric sequence. So your two formulas are your explicit. So explicit lets you find whatever term you want. So g of n equals g1. Sorry, I keep pressing a button on my stylus. Equals g1 parentheses r, oh my goodness, to the power of n minus 1. That's your explicit formula. Your recursive formula. The recursive formula is 2 lines. So in the first line, you'll put whatever your first term is. And in the second line, you'll put what you're multiplying by, and then we'll say that you keep multiplying by the previous term. Okay? So, there's 2 things that you need to know when you're writing a formula for a geometric sequence. The 2 things you need to know are the first term and the ratio. So my hint to find the ratio. So finding the ratio. So this is what you're multiplying by. You can always take the second term divided by the first term. That will always, 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 always find you your ratio. Okay, so if we take this example up here and we wanted to write an explicit formula, we would have to know 2 things. We would have to know the ratio and we would have to know the first term. So if I wanted to find the ratio, I would take the second term, 6, divided by the first term, 3, and I would get 2, which hopefully makes sense because I was multiplying by 2. So to write my formulas, I need to know that, and then I need to know that the first term is 3, and that's never a trick question, okay? It's always going to just be whatever is there first. So if I were writing the explicit formula for this, I always need more room. I always run out of room. So the explicit formula for my sequence over here would be Gn equals, I would put my first term, which is 3, and then I would put my ratio, which we said was 2, and I would put that in parentheses, and then that's going to be raised to the power of n minus 1. That's it. That's your explicit formula. Now your recursive formula is 2 lines, so we would say g1 equals, we would put our first term there, exactly as it is, and in the second line we would say gn equals, we would put our ratio, which is 2, and then everything else stays the same. So I would have my g with a small n minus 1. Because what that gn minus 1 means, you just take the previous term and you just keep multiplying and multiplying and multiplying by the previous term. That's how you get the next ones. So in our notes, we have some examples. So here we had a sequence, and to find the ratio, we took the second term divided by the first. That gave us our ratio, and we were able to plug that in to the recursive formula. Now, one other thing that you're going to need to be able to do is go back and forth. So if we look at an example from your homework, so on your homework, we said write a recursive formula for each explicit formula. So it gave it to you as an explicit formula, and you're writing the recursive. So if it's in the explicit formula, the number that doesn't have the exponent, that's your first term. So this would be your G1. The number that does, that's your ratio. So if we wanted to write the recursive formula, we would say G1 equals -4 and Gn, pretend that's a 4, this is not cooperating very well. Gn equals, we would put our ratio, and then Gn minus 1. Okay, on the next question, so on number 8, we're writing an explicit formula. So your answer is going to be an explicit formula. That means there's one line, okay? It gave you the recursive, but we're writing it in the explicit formula. If it asks for explicit, you need one line. If it asks for recursive, you need 2. So going back here, it already tells you your first term. It straight up tells you the first term is 50, and then whatever we're multiplying by is our ratio. So your explicit formula says Gn equals, you put your first term, which is 50. Again, this just is not cooperating, but 50. In parentheses, you would put your ratio. For some reason, it doesn't like me drawing 5s. And then you would raise, that's a parenthesis, you would raise that to the n minus 1. So I'm sorry this isn't really cooperating, but hopefully if you have the sound on, you're able to figure out what I'm saying here. So this is it for geometric sequences. I'm going to end the video. It's already long enough without you seeing me try to write a parenthesis. But you just need to know your explicit, your recursive. You need to go back and forth, and you need to be able to find your ratio.